Hello everyone. Welcome to MH Math Academy's KCET Crash Course 2025. In this lecture, we shall start with the chapter Inverse Trigonometric Functions. In the previous lecture, we had completed the trigonometric functions, and I hope you have, solved more problems on it, and you have also revised inverse trigonometric functions. If you haven't yet revised inverse trigonometric functions, I request you to go through NCERT first and focus on the points that I'm going to mention right now. You first focus on the domain and range of the inverse trigonometric functions, which I have given on this chart here. Okay, and then the properties of inverse trigonometric functions. The additional properties of the inverse trigonometric functions are removed now. Those properties are not in the syllabus. The only property that you have is the composition of trigonometric and inverse trigonometric functions. Okay, what are those properties? It is sine inverse of sine x is equal to x, okay, when x is in this appropriate domain, and sine of sine inverse x is equal to x, okay, again when x is in its appropriate. What do you mean by x is in the appropriate domain? What is the domain of sine x here? It is minus pi by 2 to plus pi by 2. And what is the domain of sine inverse x? It is from minus 1 to 1. So when, okay, along with this, you have the same property for cosine, tan, cot, sec and cosec also. Okay, so you please go through these properties also. And once you complete the properties, there are a few more properties that you will have to go through. That is sine inverse x plus cos inverse x is equal to pi by 2. Okay, similarly tan inverse x plus cot inverse x is pi by 2, and sec inverse x plus cosec inverse x is equal to pi by 2. Okay, so most of the PYQs that we are going to take up today are only and only based on these properties. So I request you to kindly go through this property, understand these, and then come back to solve the MCQs. Okay, so and the weightage of this chapter is going to be around 1 or 2 questions every year. Okay, so trigonometric functions and inverse trigonometric functions put together, you might get anywhere around 3 to 5 questions. Okay, so it is going to be an important domain for you. Fine, so without any further delay, let us take up a few PYQs on inverse trigonometric functions. Okay, so let us now go to the first question. The first question says, if sine inverse 2a divided by 1 plus a square and cos inverse 1 minus a square by 1 plus a square, then tan inverse of 2x divided by 1 minus a square is equal to tan inverse 2x by 1 minus x square, where a comma x belong to the interval 0 to 1. Then the value of x is, okay, so they have asked the value of x. Fine. If you look at the left hand side, okay, if you look at the left hand side, it is 2a by 1 plus a square, and this is 1 minus a square by 1 plus a square. We know that 2 tan by 1 plus tan square is going to give us sine 2 theta, right? And similarly, this is 1 minus tan square by 1 plus tan square is cos 2 theta, right? So if I substitute tan theta in the place of a, I'm going to get the simplified version of the LHS. So what I will do now is, on LHS, okay, I will put a equal to tan theta. So this will immediately imply that theta would be equal to tan inverse A, and that we will see. Okay, so sine inverse of, I'll get what, 2 tan theta divided by 1 plus tan square theta, okay, plus cos inverse of 1 minus tan square theta divided by 1 plus tan square theta is equal to, you have tan inverse of 2x divided by 1 minus x square. Fine, this is totally fine. So this implies sine inverse of, what is 2 tan theta by 1 plus tan square theta? It is going to be sine 2 theta, right? So it is sine 2 theta plus cos inverse of cos 2 theta, okay, is equal to, see whether you remember it or not, what is the uh, result for 2 tan inverse x. 2 tan inverse x is equal to, if you remember, it is tan inverse of 2x by 1 minus x square, right? So can I write down this tan inverse 2x by 1 minus x square as 2 tan inverse x? Yes, of course, yes. So it is 2 tan inverse x. Now this implies, what do I get here? Sin inverse of sin 2 theta is 2 theta plus cos inverse of cos 2 theta is 2 theta, which is equal to 2 tan inverse x. So what is 2 theta plus 2 theta? It is 4 theta, which is equal to 2 tan inverse x. Okay, so this implies, uh, what is 4 theta? I mean, what is theta? Theta is tan inverse A. So 4 times tan inverse A is equal to 2 tan inverse x. 2 ones are 2 twos are. So it is 2 tan inverse A equal tan inverse x. What is 2 tan inverse A? Again, I will use this result here. Okay, 2 tan inverse A is equal to tan inverse, right? So 2 tan inverse A is tan inverse 2A divided by 1 minus a square is equal to tan inverse x. So therefore, this will immediately imply that x is equal to this value, that is x is equal to 2a divided by 1 minus a square. Uh, Provided a should not be equal to plus or minus 1 here. Uh, yeah, a cannot be plus or minus 1 because a and x belong to this interval. So therefore, what is it? It is 2a by 1 minus a square. So it must be the option 3. Okay, so let us go to the next question. The next question says the value of 1 minus sin x plus 1 plus sin x under the root divided by under the root of 1 minus sin x minus root of 1 plus sin x is. Okay, well, look, whenever you get a question like, cot inverse of some big expression, or let's say sine inverse of some big expression, or cos inverse of some big expression, you try to express this if it is cot inverse, then you try to express it in terms of cot of something, so that cot inverse of cot something is something, right? So you can do it this way. uh, I'll try my level best to simplify this. So I will take up whatever is given here. You can see the, under the root, we have 1 minus sin x and 1 plus sin x only, both in the numerator and denominator. So I will first try to find out the value of root of 1 minus sin x. I will try to simplify it if possible. Okay. So root of 1 minus sin x, right? Okay, 1 minus, I can write this down as, I can write sin x as, we know that sin 2x is equal to what? 2 sin x into cosine x, right? So therefore, I can write down sin x as what? See, here it is 2x, so here it is x and x, so half of this angle. So sin x can be written as 2 sin, the half of this angle is going to be x by 2 cos of x by 2. I hope this is clear. So I can write down minus sin x as minus 2 sin x by 2 cosine x by 2. Okay, and I can write down one as cos square x by 2 plus sin square x by 2, right? Why? Because here anyways the angle is x by 2, so I'm going to write it down as cos square x by 2 plus sin square. So why did I do this? Is because you can see cos x by cos square x by 2 plus sin square x by 2 minus 2 cos sin is going to be of the form a square plus b square minus 2ab, right? So what is it going to be? It is a minus b whole square, that is cos x by 2 minus sin x by 2 the whole square. So if I take the root away from it, what am I going to get is cos x by 2 minus sin x by 2. So this is what I'm going to get. Okay, and if I take up this one, that is root of 1 plus sin x. Okay, similarly it is going to be what? It is going to be this one, right? That is uh, you know root of cos square x by 2 plus sin square x by 2 plus 2 sin cos. So that is going to be what? That is going to be root of cos square plus, I mean, cos plus sin whole square So that is going to be cos x by 2 plus sin x by 2. I hope what I'm doing is clear to you. Now, if I substitute these values in the problem, what am I going to get? We'll just shift this question a bit. Okay, what am I going to get is cot inverse of, okay, cot inverse of, I have root of 1 minus sin x. What is root of 1 minus sin x? It is cos of x by 2 minus sin of x by 2, okay, and then plus root of 1 plus sin x. It is plus cos x by 2 plus sin x by 2, okay, whole divided by I have again root of 1 minus sin x is cos of x by 2 minus, sorry, root of 1 minus sin, so it is sin of x by 2, okay, and then along with the minus, if I take this, it is going to minus cos of x by 2 minus sin of x by 2, okay. So this is what you get. You can see sin x by 2 and sin x by 2 will get cancelled out, and cos x by 2 and cos x by 2 will get cancelled out. I'll get cot inverse of what? Cos x by 2 plus cos x by 2 is 2 cos x by 2, okay, divided by, if you see, okay, it is going to be sin x minus sin x by 2 minus sin x by 2 is minus 2 sin x by 2, right? Minus 2 sin x by 2. So this 2 and 2 will get cancelled out. I am going to get cot inverse of minus cot x by 2, right? Minus cos by sin is minus. Now you look, cot inverse of negative, okay. When is the cot negative? If you see, cot is, I mean, the range of cot inverse x is 0 to pi, okay. In, see, 0 to pi includes first quadrant and second quadrant, right? So therefore cot is positive in the first quadrant and negative in the second quadrant, so therefore it has to be what? It has to be in the second quadrant here. So therefore what can I say is, in the second quadrant it is going to be pi minus theta, right? So therefore this will be equal to pi minus cot inverse of cot x by 2, okay, which is equal to pi minus x by 2. So cot inverse of cot x by 2 is x by 2. So therefore it is going to be pi minus x by 2. That is option 3 is the correct answer. Okay. So let us now go to the next question. That is the domain of the function cos inverse box x is. Okay. Now look, what is the domain of the function cos inverse x? If you know, it is minus 1 to 1, right? It is minus 1. So in cos inverse, okay, cos inverse of anything, if I have, let it be anything, I can substitute any value between minus 1 and plus 1, including minus 1 and plus 1, okay. But here they have given the box function, right? They have given the box function. Now look, inside cos I can put any value between minus 1 and plus 1, no doubt, okay. But here, this, since this is box x, okay, between minus 1 and 0, I will take, let's say, 0 here, it will map all the values to minus 1, and 0 will be mapped to 0. Between 0 and 1 it will map everything to 0, and at 1 it will be 1. But from 1 to 2 it will map all these fractional values to 1 again. So even if you put the values, I mean the real numbers between 1 and 2 in the place of x, it is going to give you the value 1 itself. So therefore you can substitute all these fractional values, but not 2. The moment you reach 2, it is going to give you 2. So you cannot substitute. So therefore from minus 1 I can start and I can go up to 2, but I can include minus 1, but I cannot include 2. So it is closed minus 1 and open 2. That is going to be the option 4. Okay. So let us go to the next question without any delay. The next question says tan inverse of so and so. Okay. So we will basically have to find out the value of this. Fine. We will try to do it. Tan inverse of, okay. So what is it going to be? It is 1 by root 3 sine of what is 5 pi by 12? 5 pi by 12, can I write it as 2 pi minus 5 pi by 2, 2 pi minus pi by 2? Yes. No, sorry, 2 pi plus pi by 2. Why? Because 2 2s are 4 plus 1 is going to be 5 pi by 2. Yes. Okay. Into sine inverse of, okay, sine inverse of, what is it? Cos of, what is sine root 3 by 2? It is 60 degree, right? It is pi by 3. Okay. So this is going to be equal to tan inverse of, fine, 1 by root 3. Sine of 2 pi minus theta is sine theta. So it is going to be sine pi by 2. Okay. Sine inverse of, what is cos pi by 3? It is 1 by 2, right? So this is going to be tan inverse of, okay, 1, what is sine pi by 2? It is 1, right? So 1 into 1 by root 3 is 1 by root 3. What is tan of 1 by root 3? Tan of 1 by root 3 is pi by 6 into sine inverse of 1 by 2 is pi by 6. So it is going to be pi square divided by 36. So therefore that must be the option. Okay. So they have not written as pi square by 36. Like we can also write it as pi by 6 whole square, right? So it must be the option D. That is pi by 6 the whole square. Okay. So let us now go to the next question. The next question says cos of cot inverse minus root 3 plus pi by 6. Okay. Now you see it is cos of cot inverse minus root 3 plus pi by 6. As I said, the domain of cot inverse is from 0 to pi, but from 0 to pi by 2 it is positive, and from pi by 2 to pi it is negative. So therefore what I can do is it has to be in the second quadrant. So therefore in the second quadrant, cot inverse of minus x can be written as pi minus cot inverse x. Okay, so therefore what I will do is I will write this down as pi minus cot inverse root 3 plus pi by 6. Okay, so this is going to be cos of pi minus, what is it, cot inverse of pi by 3. When is cot inverse, cot inverse of root 3? When is cot inverse root 3? It is at 30 degrees, that is pi by 6 plus pi by 6. So this pi by 6 and pi by 6 is going to get cancelled out. I'll get cos pi. What is cos pi? Minus 1. So therefore it is going to be minus 1. That is option 4. See, as you can see, most of the problems that they have asked are from very easy to easy and at the max moderate. So from inverse trigonometric functions till now they have not asked a mind-blowing question or a very difficult question in KCET. So it is an easier to handle chapter. Okay, so without any delay, let me take up the next question. The next question says cos of, okay, cos of sine inverse pi by 3 plus cosine inverse pi by 3. Okay, this is what is given. Now look, it is not sine pi by 3. It is our very much tendency that the moment we see sine and pi by 3, we will write down root 3 by 2. At the moment we see this, we will write down 1 by 2 and we miss out. Okay, it is not that. What is given is sine inverse pi by 3. If you see, the domain of sine inverse x is minus 1 to 1, right? But what is the value of pi? It is 3 point something, right? 14 something. Divided by 3 is more than 1. It is greater than 1. So what we are substituting within sine is something more than 1, which we should not substitute. So therefore this value of sine inverse pi by 3 does not exist. This does not exist. Same is the case with cosine inverse also. This also does not exist. So since cos of some value which does not exist, so cos of this is also not going to exist. So therefore the value of this does not really exist. And also when you look at sine inverse something plus cos inverse, you don't immediately write it down as pi by 2. No, it see, this becomes pi by 2 only when this and this are well within the domain. Okay, so you first check the domain and then proceed further. Okay, so that is what you have. The next question. The next question says the domain of the function defined by f of x is equal to cos inverse root of x minus 1. See, I had told you while doing the chapter relations and functions that whenever we have to find out the domain, there were two fundamental conditions that we had. One is in the denominator we should not get the square, I mean we should not get 0, and whatever is there in the whatever is there under the root must be positive. So the first thing that I'll have to note down here is x must be, I mean x minus 1 must be greater than or equal to 0, sorry, not positive, non-negative. Okay, so x greater than or equal to 1, this is the first condition that we have. Okay, x must be greater than or equal to 1, fine. The second condition is this one, that is for the cos inverse x, the domain is minus 1 to 1, right? So therefore this under root of x minus 1 must be greater than or equal to minus 1, and this must be less than or equal to 1. This is one thing that we have. Now when we take the square of it, okay, when we take the square of when you have the linear inequality like this, do not square the linear inequality just like that. That is 1 less than or equal to x minus 1 less than or equal to 1. This is absolutely nonsense. Okay, don't do it this way. But what will happen when you square? See, look, uh, you have minus, sorry, okay, you have minus 1 here and 1 here and then 0 here. Well, the squares of the numbers between 0 and 1 will lie between 0 and 1 for sure. Okay. Square of 1 is 1, the square of 0 is 0. The square of all these values are between 0 and 1 again. Not all. What will be the squares of the numbers between 0 and minus 1? It will be, those squares will also be same as the squares of these, because when you take the square of a negative number it is going to be positive, so the squares of these are also going to lie between 0 and 1. So therefore from minus 1 to 0 the squares are also going to lie between 0 and 1. So therefore when you take the square of this linear inequality, it is going to be 0 and 1, so it is x minus 1. So this is what you have. Okay, so similarly, can you tell me what is if I have, let's say, x or let's say root x greater than or equal to minus 5 and less than or equal to, let's say, uh, I'll take the lesser numbers, let's say minus 2 and then this is 3. What is it going to be? Now you look, minus 2 is here, minus 1, 0, 1, 2, 3, right? Now, the from 0 to 3, the squares are going to lie between 0 and 9, right? 0 and 9, no doubt. From 0 to minus 2, the squares are going to lie between 0 and 4, 0 and 4. So therefore, basically, you will not get any number below 0. So it must be from 0 to 4 to 9. So therefore, this it would be, when you square it, it would be 0 to 9. Okay, I hope you have understood how to deal with it. Anyways, we are going to do that in the linear inequalities. Don't worry about it. So I need the domain, right? That means the value of x. Okay. So if I add 1 on all the sets, I'll get 0 plus 1 less than or equal to x minus 1 plus 1 less than or equal to 1 plus 1. So therefore, 1 greater than or equal to x, these two will get cancelled out. I'll get 2. So therefore, x belongs to the interval from 1 to 2, including 1 and 2, that is closed interval 1 to 2. Okay. Uh, yeah, that's all. So it must be the option A. Fine. Going to the next question. The next question says if A plus pi by 2 is less than, okay, less than B, then A and B respectively are. Okay, fine. So what I'll do is I will write down the given inequality first. It is a plus pi by 2, okay, which is less than 2 tan inverse x plus 3 cot inverse x, which is again less than b. Okay, look, in 3 cot inverse x, I have 2 cot inverse x plus cot inverse x, right? Right. So what I can do is a plus pi by 2 less than 2 tan inverse x plus 2 cot inverse x. In that, if I take out 2, I'll get tan inverse x plus cot inverse x plus cot inverse x, this remaining cot inverse x, okay, less than b. This tan inverse x plus cot inverse x both put together, it is going to be pi by 2, right? Just a minute. Okay, so this value is going to be both of these put together, it is going to be pi by 2. So therefore, I'll get a plus pi by 2 less than 2 times pi by 2 is going to be pi plus cot inverse x is less than b. Okay, so this implies if I subtract pi on all the sides, I'll get a plus pi by 2 minus pi less than cot inverse x less than b minus pi. So what I am going to get is a pi by 2 minus pi is minus pi by 2 less than cot inverse x less than b minus pi. Okay, see, we know that cot inverse x, here you can see, is between 0 and pi, right? Cot inverse x is between 0 and pi. So just a minute, where is it? Which question? Yes, cot inverse x is between 0 and pi, right? So therefore this a minus pi by 2 must be 0 and b minus pi must be pi, right? So therefore a must be equal to pi by 2 and b must be equal to 2 pi. So I think it is option A. They have given respectively, so therefore a is pi by 2 and b is 2 pi. So it is option 4. Okay, so this is what we have. The next up we have this question, that is sin inverse x plus sin inverse y is equal to pi by 2, then the value of x square is equal to, okay, well, uh, if I take up this question, I have sin inverse x plus sin inverse y is equal to pi by 2. See, if we have sin inverse x plus cos inverse x, it's obviously pi by 2. So what I can write down, so this must be cos inverse x, right? This must be cos, let's see. So sin inverse x is equal to, can I write it as pi by 2 minus sin inverse y? Yes, I can write it down this way. Fine. So this implies sin inverse x. What is pi by 2 minus sin inverse y? It is cosine inverse y. It's cos inverse y. Now look, can I write down cos inverse y in terms of sin inverse? Yes. Can I write it down as sin inverse of root of 1 minus y square? Yes. How? Okay. So if you don't know how did I write this down, if I let uh, if I let this cos inverse y to be some theta, okay, then cos theta is going to be y, that is y by 1, right? So if I take a triangle here, this is theta, okay, cos theta is what? Adjacent side by hypotenuse. What is the adjacent side? Y. What is the hypotenuse? It is 1. Okay, so what is this going to be? This is going to be the root of hypotenuse square minus y square, right? Now if you take sine theta in this triangle, what is it going to be? It is opposite side by hypotenuse, that is root of 1 minus y square. So theta is going to be sine inverse of root of 1 minus y square, right? So this is, I mean, theta is cosine inverse y. So theta is also equal to, so therefore this must be equal to sine inverse of root of 1 minus y square, right? So this is what you have. So sine inverse x is equal to sine inverse of root of 1 minus y square. This will immediately give us x equal to root of 1 minus y square. So no, they have asked the value of x square. So if we square it, x square would be 1 minus y square. So what is it? It is option 1. So this is the correct answer. Okay. So let us now go to the next question. Okay, the next question, see, this question has also been repeated. Okay, so the next question says A is equal to 1 by pi of this matrix, B is equal to 1 by pi of this matrix, then A minus B is. Okay, it looks very, you know, difficult, but it is not so. Okay, we will take out A minus B and then let's see what will happen. Okay, A minus B is equal to, you can see in A and B we have 1 by pi common, so I will take out 1 by pi and I will directly subtract it. I'll get sine inverse of pi by, I mean pi x, see, I have to do A minus B, right? So minus into minus is going to be plus cos inverse pi by, sorry, pi x. Okay, and then the next term would be tan inverse x by pi minus into plus is going to be minus tan inverse x by pi. Okay, and then I'll get similarly sine inverse x by pi minus sine inverse x by pi. I hope I don't have to explain this plus or minus, etc. I have done it. Okay, the next thing is cot inverse pi x minus into minus plus tan inverse pi x. Okay, so this is what you have. And you might ask me, how sure am I that this pi x and pi x belong to the domain of sine inverse? If nothing is given, and if we don't know the value, and if there is a variable involved in it, then we can assume that it is well within the domain. So I will assume that it is within the domain. Okay, so this is equal to 1 by pi. What is just a minute. What is sine inverse x plus cos inverse x? Pi by 2. So sine inverse pi x plus cos inverse x pi, cos inverse pi x is also pi by 2. Tan inverse will get cancelled out. I'll get 0. This and this will get cancelled out. Okay, I'll get 0, and this again I'll get pi by. Okay, so this is equal to, now you can see if I take this pi inside, 1 by pi inside, I'll get 1 by pi into pi by 2. 1 by pi into 0 is 0, this is 0. 1 by pi into pi by 2. Pi and pi will get cancelled out. I'll get what? 1 by 2, 0, 0, 1 by 2. If I take out 1 by 2, I'm going to get 1, 0, 0, 1. Why did I take out 1 by 2? Because the answers that they have given are in terms of I. What is I? I is the identity matrix. Okay, so it is going to be 1 by 2. What is 1, 0, 0, 1? It is the identity matrix I. So therefore, it must be the option 4. The fourth option is correct, since to be almost obvious. Okay, so these are a few questions from the previous year KCET questions. I think I have covered almost all the questions, not all, because I have skipped a few. I think max to max 1 or 2 questions, which were very easy and very direct, and I didn't want to waste time on those questions, so I have skipped 1 or 2. Except that from 2016 to 2023, I have covered all the possible previous year questions in this lecture. I request that you go through the previous year questions once again, try to solve all the previous year questions, whichever you get. Okay, even the 2024 previous year questions. Okay, make sure you revise this well. You are definitely going to get 1 or 2 questions from this chapter. Okay, so in the next lecture, I will see you with the chapters limit and continuity. Okay.